You see straight lines literally everywhere. But what if I told you they have a secret language? A language that lets us describe any line, anywhere, with perfect precision. Today, we're going to learn how to speak it. And believe it or not, it all starts with a simple, powerful feeling.
Okay, just imagine you're at the bottom of a mountain, right? You see a couple of different paths. Some look like a gentle stroll. Others, well, they look like a brutal, steep climb. You don't need any numbers to know which one's going to be harder. You can just feel it. That gut feeling of steepness is exactly what we're going to talk about. And in math, that feeling has a special name.
And that name is slope, or sometimes you'll hear it called gradient. It's pretty much just the official mathematical word for steepness. It's how we take that intuitive feeling of a tough climb and turn it into one single solid number. So how do we actually do that? How do we put a number to that climb? Well, it turns out there are a couple of main ways to measure steepness, and each one is useful in different situations.
The first way uses the angle of the climb. If you can measure the angle a line makes with the ground, a little tool from trigonometry called the tangent will give you the slope. Just think of it like this. It's a function that translates the tilt of that angle directly into a number for its steepness.
But hey, what if you don't know the angle? No problem at all. If you can just find any 2 points on that line, you can use method 2. All you have to do is measure the vertical change between them. We call that the rise. And divide it by the horizontal change, which we call the run. Rise over run. It's as simple as that.
So here we have two totally different paths to the exact same destination. Whether you start with an angle or you start with 2 points, both of these formulas are going to give you the very same number, m, the slope. And this is the key because it's one single powerful number that really captures the line's entire personality. And this is where the power of m really starts to show itself. That one little number doesn't just describe how steep something is. It holds all of a line's secrets. It unlocks a ton of information about how it's going to behave. You want to know if two lines will ever meet? Just look at their slopes. Seriously. If the slopes are identical, the lines are parallel. They're just going to run alongside each other forever. And if you multiply their slopes and get -1, bam, they're perfectly perpendicular, meeting at a perfect 90-degree angle. The slope instantly tells you everything about their relationship. The slope even tells a story all by itself. A positive number? That means you're climbing uphill. A negative number? Now you're heading down. A slope of 0 is just perfectly flat ground. And an undefined slope? Well, that's a vertical line, kind of like trying to climb a sheer cliff. All right, we know how to find a line's slope and we know what it means. Now let's use it for the grand finale, giving every single line its own unique address in the universe, its equation. This formula right here is the master key. You only need 2 pieces of info. First, the slope, m, which sets the direction, and second, any single point on that line, which basically anchors it in a specific spot. You plug those 2 things into this point-slope formula, and you've got it. The unique equation for that one specific line. Just stop and think about that for a second. With one simple formula, we can create a unique algebraic address for pretty much every single straight line you can possibly imagine. That is an incredibly powerful idea. And it's an idea that truly revolutionized how we see the world. I mean, this wasn't just some small step forward. It was a giant leap that connected 2 entirely separate worlds of thinking. For centuries, you had geometry, the world of shapes over here, and algebra, the world of equations, way over there. They were completely separate. Then, in 1637, this brilliant mathematician, René Descartes, published a book that built a bridge between them. He showed us that we could actually describe shapes using equations. This merger, which we now call analytical geometry, lets us translate the visual into the algebraic, and the other way around. And that brings us to a final, maybe more profound idea. Learning this secret language isn't just about passing a math test. It's about taking part in this grand human tradition of finding patterns to make sense of our universe. It's about, as this quote puts it so well, feeling the power of our own minds to figure things out. Thanks for joining us today.